Today we're going to talk about the chaos theory, which is about finding underlying order in apparently random data. The first person to ever experiment in chaos was a man named Edward Lorenz. He was a meteorologist, which means he studied the weather. He was trying to find a way to predict the weather, so he set up a computer with a series of 12 equations, which would print out, theoretically, what the weather should be. One day in 1961, Lorenz wanted to see a certain sequence again. To save time, he entered a value from the middle of the equation, but he only entered it up to 3 decimal places when the program had entered it up to 6. When he came back a couple hours later to see how the sequence had turned out, the numbers were wildly different from the original. This tiny difference that caused the equation to spin wildly off track is now called the butterfly effect. Lorenz's original program had 12 equations, but he wanted something simpler that would still display the butterfly effect, and he ended up with 3. You've also found that when graphed, this series made a double spiral shape, which we now call the Lorenz attractor. The next person to experiment in chaos was a man named Robert May. He was a biologist, so he studied living things. He wanted to see how growth rate would affect a population from the equation next year's population equals r times this year's population times 1 minus this year's population, with r being the growth rate. He noticed that once the growth rate passed 3, the results jumped between 2 possible populations. After the growth rate increased further, the results became totally chaotic. This has been the chaos theory in a nutshell, and I hope you enjoy the rest of our presentation.